Hello, 5th graders, and welcome to a read-aloud of our very first ebook for our science course this year. Now, in case you didn't know, the term ebook is actually short for electronic book, meaning it's a book that's available only digitally, only online. You may have noticed that you did not receive any physical or real books in your science materials this year, because all the books are going to be available just on the computer, okay? Case in point, our very first ebook for our second science lesson for the year, that being Science Lesson 1.2, Science and Engineering. The first ebook we're going to read together is going to be this one here called Experts in Engineering. So it's a pretty fascinating book. It'll show us all about some of the really great engineering projects that human beings have created throughout the years. Things like bridges and tunnels and buildings. So I do look forward to diving into this one with you folks. Just know in the future, whenever you see in your science lesson an ebook, it's going to get the nice big button that says Open eBook, and before you do, make sure you pay close attention to what pages it tells you to read, okay? Right here it's telling us to read pages 4 through 29, which in this case is really going to be the whole book, but some of the future ones may only ask you to read a few pages. So make sure you pay close attention to that before you open the ebook and start reading, okay? That said, let's go and dive into the first one today. Open ebook, and here we are. Now you may not be able to see them on screen right now, but down below there are buttons for zooming in and out, and on the left and right sides are buttons for turning the page. I do want to zoom in a little bit so we'll be able to see it a little better, and I'll start turning the page for us, okay? So Experts in Engineering. Let's dive into it. So page 4, that's where we're starting. And just so you know, I'll only be reading the main part of each page, okay? There's a lot of extra little bits of reading around the outsides of the pages. I don't want to read all of those right now only because it would take a little long, but obviously if you are really interested in what we're reading and you want to be able to check these out more closely for yourself, you are free to do so, okay? But I'll just be reading the main title of each page and the main paragraph on each page, and maybe giving you some more little details myself. So at this time, let's go and get into it. The Engineering Challenge. Civil engineers design and build structures such as bridges, buildings, and tunnels. Architects and engineers need to make sure the structures they design and build are strong enough to withstand forces such as high winds or shaking from earthquakes. So talking about like bridges and cranes and buildings and the like. Got to be strong enough in order to withstand all those forces so they don't fall down. Great Pyramid of Giza. The Great Pyramid was built in 2560 BCE. At 480 feet, or 146 meters, it was the tallest of the 3 pyramids of Giza in Egypt, and the highest building in the world for 3,800 years. It is the oldest of the structures known as the 7 Wonders of the World, and the only one still standing today. So it's still a bit of a mystery how the ancient Egyptians were able to build such huge structures. Obviously they didn't have things we have today like cranes and trucks that would have helped to move those big stones around and stack them on top of each other like this. Maybe one day we'll find out. Next up, laying down tracks, talking about trains. Steam-powered locomotives, or steam-powered trains, were invented in the early 1800s, marking the start of the railway age. These heavy machines needed parallel iron tracks to run on. The first tracks to carry passenger trains were built in England in the early 1800s. So that picture right there is a picture of one of the earliest steam engines. It's actually called Locomotion Number 1. Look at that little guy, chugging along. Now it's impressive to think that after more than 200 years, we now have trains that look something like this. That's a maglev train. And it's called that because it actually runs on a magnetic track. In fact, it doesn't even have wheels. It actually kind of uses the power of the magnets to hover or float above a few inches above the track. As a result, it's really, really fast. I think some of these things can travel almost 400 miles per hour. So we sure have come a long way in train technology. Next up, warning lights. Lighthouses. A lighthouse is a tower that sends out a beam of light to warn ships of hazardous waters or rocks. The earliest lighthouses were iron baskets filled with burning wood or coal and mounted on long poles. The fires were replaced by oil lamps in the 1700s. And electric bulbs were used starting in 1875. And that's, of course, what we still use today. So anytime you go to a shoreline with a lot of rocks, you're probably bound to see a lighthouse there to try to keep the boats safe. Boring a tunnel. The Thames River, under the River Thames in London, England, was the first tunnel to be built under a navigable river. So they actually drilled a tunnel underneath a river, which means a river large enough for ships to use. The tunnel took 18 years to complete and opened to the public in 1843. So 18 years is a long time to dig a tunnel. Nowadays, we have big old boring machines that look like this. You can kind of think of them like huge drills that just drill right through this side of a cliff or the side of a mountain in order to bore out this huge round tunnel. With something like this nowadays, building a tunnel could probably take less than a year. What took 18 years back then, much faster now. Spreading the load, now talking about bridges. When designing bridges, engineers must consider the forces that put stress on bridges, such as compression, which is pushing inward, and tension, which is pulling outward. Different bridge designs balance these forces in specific ways to prevent the bridge from falling or collapsing. So if you take a look at some of those different diagrams over here and the different types of bridges out there, like suspension bridges, beam bridges, arch bridges, and cable bridges. If you look carefully at those diagrams, the blue arrows show you where there's compression, and the green arrows show you where there's tension. And you got to make sure that when you design a bridge, the tension and the compression are balanced with one another so that the bridge stays upright and strong and doesn't collapse. Next up, towering giants. Talking about some tall buildings today. Specifically, this one right here, you may know that as the Eiffel Tower in Paris, France. Built for the Paris exhibition in 1889, the Eiffel Tower is a four-sided pyramid made of wrought iron. The tower's strength comes from its frame, which is made up of parallelograms, which are these four-sided shapes right there, and triangles. So you can see a lot of triangles in the design as well. Using a minimal amount of material, 186 of those triangles spread the weight evenly, making the structure extremely strong. And if you wonder why that thing is called the Eiffel Tower, it's because its designer was this man right here, Gustave Eiffel. And it once was the tallest building in the world, at least in the year 1889, about 130 years ago or so. But it has been since passed up by some taller buildings, like the Empire State Building in New York, the Burj Khalifa in Dubai, and they're actually building an even taller building right now called the Jeddah Tower. That's going to be in Saudi Arabia. They haven't finished building it, but when they do finish it, it will be the tallest building in the world. It's going to be 1 kilometer tall, is what I've heard. Pretty impressive. Next up, linking the oceans. The Panama Canal opened in 1914. It cut across the country of Panama in Central America and linked the Atlantic and Pacific Oceans. The new, safer route from ocean to ocean avoided the dangerous voyage around South America. First attempted by the French, the canal was eventually built by the United States. It took nearly 10 years to build and required tens of thousands of workers. Now, for a bit of context here, I can actually show you guys on Google Maps. So why was the Panama Canal built? Well, imagine for a minute that we over here in California wanted to travel over to, say, over the Atlantic Ocean to, say, the country of Portugal over there in Europe. Back in the day, if you wanted to make that voyage by ocean, you would have had to depart from California and sail all the way down here around the southern tip of South America, and then all the way up here, up through the Atlantic Ocean, all the way to Portugal. So you can imagine that was a very, very long journey. It probably would have taken months. And so somebody got the bright idea that, hey, how about instead of going all the way around South America, what if we check out this country called Panama right here, on this little strip of land connecting North America and South America, and if there was just some way that boats could travel through or over Panama, we'd be able to get from one ocean to the other a lot faster, and it'd make that boat journey a lot shorter. So some brilliant engineers found out that if they just dug up this strip of land right here, this kind of sandy looking part, this all used to be land, but those engineers were able to design the canal and dig it all out to let the water through. So now ships are able to pass through here and easily pass from one ocean to the other. So considered one of the greatest engineering feats in human history. Very, very important. So this page is sideways, but I'm sure if I turn my head, I'll be able to read this one. It says, building high in the sky. The word skyscraper was the first used in the 1880s to describe buildings with more than 10 floors. Now, some of the highest skyscrapers have over 100 floors. The oldest of these is the Empire State Building in New York. We saw that one earlier. Of course, certainly not the tallest anymore, but it was at one time. Next up, holding back the flow. I think these are referring to dams. Dams are built on rivers to create reservoirs for water supply, to protect against flooding, or to generate electricity through hydroelectric power. Now, while we certainly can get some of our electricity from water flowing over dams or through dams, we can also get our power from the wind in the form of wind energy, or wind turbines like these. People have harnessed the power of the wind for centuries using windmills. Modern wind turbines are much more powerful and are used to generate electricity in a clean, renewable way. The first wind turbine capable of generating more than 1 megawatt, or 1 million watts, of power was designed in 1941 by American engineer Palmer Coslet Putnam. So if you've ever driven through the California desert, you probably have seen big old wind farms like this. More and more we're starting to get more of our electricity from wind farms, which I think is a good thing. Next up, zero gravity engineering. So talking about some of the engineering of our spacecraft where our astronauts lived. Some scientists spend months living and working in space stations, such as the International Space Station. Space engineers face many problems when designing modules, or like little rooms, for people to live in zero gravity conditions. Without gravity to hold objects or people down, everything floats around. Simple things, such as eating and going to the bathroom, can be very difficult. So we're so used to having gravity here on Earth. Imagine trying to design a home that's comfortable to live in where people don't have any gravity. It takes some brilliant engineers to do so. Next up, get ready for takeoff. When building airport runways, those being the long strips of tarmac or concrete that airplanes have to pick up speed in order to be able to take off, engineers must take many factors into account. They need to build the runway to minimize the chance of dangerous crosswinds blowing across it. Those could be quite dangerous. The runways also need to be as flat as possible and must provide good grip for the aircraft's wheels. Now with that, my friends, there is a glossary you could check out with all the terms that you may have come across in the ebook today, answers to some of the challenge questions if you happen to try any of those. But with that, my friends, I'm happy to say that we have successfully completed the main content of our very first ebook in our science course today. So when you're finished, you could just go up to the button in the upper left corner that says back to the activity. And then from there, just resume your science lesson as normal, okay? So with that, I'm very glad to have completed that with you today. Be sure to do your best, everyone, and be looking forward to the next ebook that I'll provide a read-aloud for you guys, okay? So take care, have a great day, keep up the fine work. We'll see you soon.